Neil deGrasse Tyson once said, Proxima B is an Earth-like planet that orbits the closest star to the Sun, which is what makes it interesting. Now, scientists are in awe of the clearest image yet captured by the James Webb Telescope of a planet that resembles Earth. Proxima B may be the first exoplanet that humans use probes to investigate. It is just roughly 4 light-years distant. Researchers are constructing numerous spaceships to investigate the inhabitants of Proxima B and determine whether they are amiable in light of the startling information on this planet. One exoplanet that is an exception is Proxima B. This planet is one of the closest celestial planets outside of our solar system in the cosmos, little over 4 light-years distant from us. For millennia, astronomers have been baffled by the Proxima Centauri system. Alpha Centauri was believed to be our nearest stellar neighbor for a long time, but then unexpected things continued happening. First, researchers discovered that Alpha Centauri is actually a double star rather than a typical star. We were once again taken aback by this enigmatic system in our near-galactic neighborhood a few decades later. With ever-improving telescopes, modern astronomers have once again discovered abnormalities in the Alpha Centauri system that astound them. At last, scientists discovered a third star as the cause of these irregularities. But the Alpha Centauri system's third star didn't seem to be just a trilling of the 2 stars that were already known. The celebrity was, and still is, too noticeable for that. Despite having a direct orbital connection to the other 2 stars, Proxima Centauri moves through space at a distance that is far from their orbits. Scientists came to the conclusion that the third star might be stuck as a result of the gravitational force of Alpha Centauri A and B. Since then, the 3 have been performing a common dance throughout the universe. One of the first near-Earth exoplanets to be found was Proxima Centauri B in 2016. The discovery caused a stir. Proxima Centauri B's real nature is currently being revealed by the James Webb Telescope. It's possible that Proxima Centauri B is the nearest inhabited planet to Earth. We might even be able to visit this place in the not-too-distant future, which makes this amazing. When humans are able to construct interstellar spaceships, Proxima Centauri B will undoubtedly be among our first stops. However, we have even more fascinating information regarding this. Let's start by examining this planet's wonders, which are thought to be similar to Earth. Proxima Centauri B is somewhat denser and larger than Earth. Since it has been recognized as a rocky planet, it has a solid surface throughout, in contrast to gas planets. A year on Proxima Centauri B lasts only 11 days because of the planet's extremely close orbit around its star. This doesn't sound very homely at first, because it's hot at least in our system near a star. The star in the Proxima Centauri system, however, is not quite as bright as our Sun. Proxima Centauri B is so unmistakably located in its star's habitable zone. The planet might actually be an Earth 2.0 with a temperate climate and life, if it also contains water. The James Webb Space Telescope is a perfect example of this. Our technology is unable to verify whether Proxima Centauri B has water and an atmosphere, despite the fact that the planet has been known for a long time, and there has been considerable conjecture over its true nature. It is obvious that the Webb mission's objectives are to learn these details about Proxima Centauri B, as well as a host of additional exoplanets that may resemble Earth and be inhabited. The first precise studies of the environments of far-off planets can be produced by Webb using its special technologies. The telescope accomplishes this by using a brand new kind of spectrometer technology that uses infrared light rather than visible light. Very far away or faint celestial bodies can also release infrared light rays. In fact, the long voyage to us causes the light to change into the red color spectrum. James Webb can now easily do what Hubble, which uses only visible light, could not. This powerful super telescope captures and transforms even the weakest signals from far-off stars that have traveled billions of light-years into viewable images. When it comes to exoplanets, the technology gives us accurate information about a planet's cosmic scale environment. Like grains of sand or dust, exoplanets are small in relation to their stars and are unable to produce light on their own. But scientists use their ability to reflect light to find them. Consider how the light from an exoplanet's star is first absorbed by it, then combines with the atmosphere and is reflected off the planet's surface. Sunlight that has been absorbed and reflected in this manner is the only source of light that we can see on Earth, and that provides us with pleasant warmth. Proxima B alters the light from its star during these events, and the sun's light is altered as well. A subtle but noticeable light spectrum is released if the light interacts with specific gases in the environment or even encourages the gases' reaction and heating processes. There are hundreds or thousands of distinct light waves in this spectrum, and every gas and element creates a distinctive signature that is easily recognized by everyone. To put it simply, this indicates that the oxygen in Proxima B's environment emits wavelengths that are comparable to those of oxygen in Earth's environment. The tiniest water droplets in a planet's ecosystem are no different. Scientists can then make additional inferences on the amounts of water on the planet's surface based on the amount of water observed in the planet's surroundings. Would you have ever considered the possibility that there are other livable planets in the cosmos? Or were you among those who are adamant that the Earth is the only planet in the universe? Imagine a habitable water world with continents and life. Straight to the point, there are some planets that are remarkably similar to Earth, and Proxima B is one of them. However, no planet will ever be precisely like Earth, not even two snowflakes are exactly alike. A real super-Earth is slightly larger, slightly warmer, and slightly heavier than Earth, according to scientists. Large volumes of water and evenly spaced landmasses would characterize such a world. The star would last roughly twice as long as our Sun, and the environment would be mild and uniformly warm. According to evolutionary researchers, super-civilizations might potentially emerge with this extended system lifespan. And we're looking for exactly these kinds of civilizations in the cosmos. Imagine that somewhere in our galactic neighborhood, there is a highly technical and sophisticated species that is also amiable and eager to make contact. Such species could likely teach us a lot. Although it still seems far off, scientists and engineers are constantly striving to become proficient in interplanetary and eventually interstellar space travel. Proxima B in only 20 years? In a few years, spaceships will be traveling to Proxima B if Russian billionaire and space enthusiast Yuri Milner has his way. The sole instruments on board the first of these tiny spacecraft will be a camera and a few simple measurement devices. Nonetheless, the apparatus ought to be adequate to give us the first authentic images from the Proxima system and ultimately demonstrate whether or not Proxima B is home to life. The probes, which are only a few millimeters in size, will reach Proxima B in less than 10 years by traveling at nearly the speed of light thanks to a special acceleration technology. As early as the middle of the 1930s, we might have the first images of an exoplanet. Whether Proxima B is blue, green, and white like Earth, or brown, black, or even red, will be a surprise when we view the planet's atmosphere and colors for the first time. We are aware that Proxima B most likely has a bound orbit around its star because of observations made by the world's greatest telescopes. It has two sides, day and night. It never gets dark on the day side, and it's probably too hot for life. It is constantly dark and perhaps quite cold on the night side. The intriguing aspect of this planet is that it has a transition zone that circles it, and life may exist there. We find it absurd that a planet can only support life on a strip of several thousand kilometers, with one side experiencing perpetual heat and brightness, and the other side experiencing cold and darkness. The planet would not be a real twin of Earth in that sense. We must take into account additional life possibilities and forms that defy our preconceived notions in our quest for extraterrestrial life. The intriguing topic of whether we would then be able to visit Proxima B ourselves is naturally brought up by this. Indeed, a lot of experts are positive that we will soon be able to build spaceships with engines that can travel nearly as fast as light as long as we keep improving the level of technology. In roughly 20 years, trips to Proxima B would most likely be feasible. We are still unsure of how we will deal with issues like cosmic radiation's consequences and the universe's weightlessness. In this sense, everything depends on how the warp drive develops. This should make it possible to move around the universe's space-time structure without using fuel. The drive, which we are all familiar with from science fiction movies like Star Wars, is theoretically already present. However, the energy issue has thus far prevented us from moving forward. However, encouraging improvement is ongoing here as well. In 2022, American researchers were able to create a miniature warp bubble. This bubble has the ability to extend space-time such that tangible items, including humans and spaceships, can easily pass through a fold to traverse great distances. Then, we would require very little time and relatively little fuel. All we need is the ability to produce such a bubble on a massive scale, which will require energy. Alternative energies, like negative matter or even the enigmatic dark energy, would hold the key to the solution. In addition to being free of space and time, spacemen would also be free from cosmic radiation stressors and effects like time dilation if the warp drive is successful. Subscribe to the channel right now. We consistently release intriguing new videos.